Hello, everyone. My name is Batu Aitemis, and thank you for coming to this talk. Please silence your phones, and let's get started. Today, I'm going to present to you your buddy, the Grandmaster, repurposing the game-playing AI surplus. Sorry, I missed a word there. Let's just add it. Repurposing the academic. Yeah. Let's make that bold. Let's make that bright. And let's get back to it. Okay. Repurposing the academic game-playing AI surplus for inclusivity. Let's start with the conclusion. I want all of us to use our game-playing AI capabilities to assist our players. But before we go much deeper into that, who am I? I'm the vice director of Inog. Inog is a game development community back home in Turkey, and I'm also in charge of writing our Medium blog posts, and I'm the editor. If you know Turkish, I would highly recommend you check this out. I'm also a PhD student at the University of California, Santa Cruz. If you're curious as to why there's a slug in the background, that's because that's our lovely mascot, Go Banana Slugs. My PhD research is on game design and AI research. But the AI agents that I make definitely do not look like this. They more behave like this. My current research is on using reinforcement learning for navigation, so my agents usually just bop their head. And I'm also a game developer. I have a self-imposed rule of at least participating in at least 2 game jams every year, and I try to keep up a practice of actually designing and developing and publishing games. I think that helps me in touch with what's going on to some extent. And I had the opportunity to work at Ubisoft Montreal 2 years ago. That was a 6-month-long internship. I worked at the Ubisoft LaForge Research and Development Lab. During there, my mandate was using reinforcement learning to assist in or solve highly complex physics-based navigation, so point-to-point navigation. And the project that you see on the screen, I worked on the initial stages of this one. I also spent 3 months in Microsoft Research Cambridge in the Game Intelligence Lab. In this team, my work was on making reinforcement learning more amenable, let's say, to designers. So we had an idea of a designer-centered reinforcement learning, where a designer could come in and use their preferences to shape the style of the agent. It was interesting work, but that's not where we are here for today. So, story time. Let's start with a few stories. So a few years ago, I was at an academic conference at AID. If you're not familiar, this is how all academic conferences look. You have fun, you laugh, like, haha, it's beautiful, you should join. And during that actually relatively decent fun dinner, I was having a conversation with the people around. We were talking about the games we played, all that lovely stuff. And then a waiter approached us and joined in on the conversation. It was really nice. We talked about our shared love for games, and we shared what games we liked to play. And then the waiter asked, like, oh, where do you play these games? And we said PC. The context was we were playing Dota, I think. And he responded, and he said, oh, I would never be able to play computer games. There are too many keys. And I was like, okay, interesting. Well, and then I moved on. I was back home in Turkey a few years ago during Christmas break, and I was having a conversation with my mom. Obviously, we were drinking tea. And this was one of those existential conversations, like reflecting on the past, thinking about what's to come. And obviously, I'm giving a talk at a game developer conference, so obviously games was a big part of me growing up. Maybe that's not obvious. Not everyone needs to be in games in GDC, but besides the point. But one thing that I never shared with my mom was that love of games, right? We never played together. She knew I was interested in it. She knows that I'm getting a PhD, and growing up, that was the case as well. So I asked her, why didn't you play games with me growing up? And this was her answer. I didn't play games with you because they made me feel incompetent. And I said, like, Mom, you suck. And then I moved on. A few months ago, I was on Twitter, and I saw this tweet by my prof, Tad. He's someone I really look up to, and he's a really, really effective designer. He was saying, Below is my favorite game in 2019. Great, it's on sale. So I was like, yeah, let me buy this game so I can play it, and then I can talk to Tad about like the design. It would be a lovely conversation. It would be great. I was very excited. Then I bought the game, and I just couldn't play it. I couldn't understand it. I got stuck. I got lost. I couldn't find my way through it. And after 40 minutes of meandering around, I just gave up. And I just couldn't share that experience with Tad. Like, I couldn't go up to him and say, like, oh, the design was great. Like, oh, the level 17, it was beautiful. It just, like, I bounced off. And with bouncing off from that game, I also bounced off from this shared experience. In all of these different examples, game make people feel incompetent or helpless. And that's not good, right? When a game rejects a player, they're not only rejected from the contents of the game. I mean, sure, you can't play the game, right? That's fine. But there's also this social network that we build around the games. If I can't play Valheim, I can't play with my friends and participate in that friend group conversation. If I can't play my favorite games, I wouldn't be a part of the fan group that is built around it. Or I might not be able to start modding and be a part of that community. Or similarly, I wouldn't be able to speedrun and share the joys and winning of understanding, exploring that experience, right? So when a player is rejected from a game due to any reason, accessibility reasons, difficulty reasons, what have you, they're not only rejected from the game itself, but also the communities and the social structures that are built around it. And this is very important. And because of these, we need to ensure games are inclusive. Not for the sake of games themselves, but for the sake of people who play them. I keep saying this word inclusive here and in the title. Let's go a little bit deeper and explain what I mean by that. It comes from inclusive design. And inclusive design is a method that is developing a diversity of ways for everyone to participate in an experience with a sense of belonging. Right? People are diverse. That's not an outrageous claim. And there are many axes in which people could be diverse, right? And one of them is ability, where when I was thinking a few years ago, my understanding of disability and ability was very rigid. I thought, like, okay, let's say you have only one arm, you're disabled when it comes to touching. Let's say you're blind, you're disabled when it comes to seeing, and so on and so forth. But I've come to learn that disability isn't necessarily an attribute of the person that is associated with the person, but rather it's an attribute between the person and the context they're in. More specifically, disability arises through a mismatch between a person and the context they're in. Right. So when I started assuming that perspective in looking at this type of diversity, I've learned, disabilities could be temporary or they could be situational. Any new parent would know what I'm talking about. I'm not a parent, but I have a nephew. So then the questions start rising, and based on the experience I had with those conversations and my own experience of feeling helpless, how can we make games more inclusive? Assist modes came to the rescue. And this is not the only way. It's not the only way to make games more inclusive, but it's a good start. So let's talk about what assist modes are. Celeste. Show of hands for everyone who played Celeste. Everyone raises their hand. Celeste is a 2D platformer for those who haven't played. It's really difficult. The whole premise is about Madeline overcoming her difficulties in climbing the Celeste Mountain. And it's really difficult. But in Celeste, there's a mode called Assist Mode. I'm going to read it out loud to describe what it does. Celeste Assist Mode allows you to modify the game's rules to reduce its difficulty. This includes options such as slowing the game speed, granting yourself invincibility or infinite stamina, and skipping chapters entirely. Effectively, it exposes a few tuning knobs that the player can adjust, such as the game speed, whether to give yourself infinite stamina, how many air dashes you have, whether you're invincible and all that. And it's up to the player to make these choices. It actually makes it very easy for the player to customize the game to their own experience. Right? So assist modes are really good at bridging this gap and reducing the mismatches between the players and the games. Another assist mode I use is from Mario Odyssey. In that assist mode, if you turn it on, you actually start seeing some arrows, and if you fall down, arrows leading you to your goal. If you fall down, you just get back. I had my arm broken, collarbone last year, and it was very helpful to have an easier game because I couldn't really move and it was like painful. So having an easier time made it good. So that was a temporary disability that I experienced, and the assist mode helped me overcome that. In another context, I actually realized I had a situational disability with seeing how all the the game was being played. I was playing the game on a projector, and during the day, I really couldn't tell what was going on. So putting on the arrows to help me with navigation actually helped me with navigating. Even though I have pretty good eyesight with glasses, in that situation, there was a mismatch between me and the game, and the assist mode helped me overcome that. Let's go back to our conclusion. Use your game playing AI capabilities to assist your players. And when I say assist, this is the type of thinking that I'm drawing upon. Now let's look at the other side of this equation. Game playing AI capabilities. What are those? Another story time. 2013, I'm an undergrad. I don't think I have... Yeah, I'm a senior, I think. This paper came out. Playing Atari with deep reinforcement learning. Made big waves. This is one of the first papers that really put deep reinforcement learning into the mainstream eye. And the idea there was they managed to competently play Atari games using pixels. So pixel input comes into the system. There's some learning that is being done. And then the agent outputs an action, and that allows it to play the game competently. My response was like, yeah, game AI solved. Let me just describe what reinforcement learning is. So let's say you have a racing game, and you want to make an AI to play this game competently. Instead of writing the rules, handcrafting the rules, saying like, oh, if there's a curve, turn right, if there's an obstacle, stop, like instead of writing those down, what you do is you write down the goal. You say, okay, agent, your goal is to cross the finish line as fast as possible. If you cross it, +1 point, good job. If you don't cross it, -1 point, bad job. And the agent takes this goal and starts doing random actions. And then eventually it makes a little bit of a progress towards the goal and gets a point. I was like, ooh, that point was good. So it keeps doing more and more and more. And at the end of the day, if everything is right, and if you didn't anger the variance gods, then you get a check mark and a good agent that actually can play the game. And apparently this idea had legs because a lot more deep reinforcement learning papers and projects started coming out in the following years. So we managed to solve AlphaGo. I guess we can call it solved because AlphaGo managed to beat the world's best player. The next step, OpenAI managed to beat really, really good Dota 2 players. And then recently, last year, 2 years ago, some time ago, DeepMind managed to beat really, really good StarCraft 2 players using deep reinforcement learning models. And as an outsider looking at these, I was like, yeah, we can obliterate our players. Amazing. Game AI solved. Beautiful. Between 2013 and now, thankfully, I also grew as a game designer, and I started watching AI Summit. And, oh yeah, obliterate, there's a big star there. We're going to go back to it. One thing that I've learned is like, yeah, obliterating our players isn't the goal when you're making the games that we make. And let's focus on that word obliterate. Like I'm talking about deep reinforcement learning, but if we were to actually use them in our games, we wouldn't. If we wanted to obliterate our players, we wouldn't use deep reinforcement learning. Maybe a star, maybe Monte Carlo tree search, maybe Minimax, witchcraft, could be. If you're really, really out there and like experimental, you could use if statements. For the purpose of this talk and the ideas that I want to present and give across, I guess, the specific details don't matter, right? You're using deep reinforcement learning or MCTS or if statements. At the end of the day, you have a black box that is competent game playing AI. Something comes in, agent does something, you can play the game. Right? And we have this competent game playing AI somehow. And it is good if we use it, especially the academic side of it, because decades of research went into it. And also a lot of investment, like especially in the deep reinforcement learning camp, like a lot of investment went into this. Right? So it would be good if the games industry could use some of that. But then the question is like, we have this capability, we have this engine that can really do stuff that is very powerful. Yeah, but what can we do with this? This is a black box, so what can we do with this black box? And the key is like, yeah, obliterating our players isn't the goal, and yet this box is really good at obliterating the player. So how do you reconcile that? Well, conclusion, use the game playing AI capabilities to assist your players. But then, like, we already have this, right? Like, why would you go above and beyond and then use these complicated AI techniques when you can do this? And honestly, these type of simple assist modes get you most of the way. But I think we can do more, right? Just to brainstorm some ideas as to what it could look like. For example, you can have a system in a real-time strategy game. Let's get Alpha Star. where AlphaStar, our AI system, focus on the microing of the units. And in this case, specifically moving one unit from here to there and like baneling splitting and all those types of things. Whereas the player is now the commander and their only task is to build factories and organize the economics and do all that. And this would be really cool. A lot of people, I assume, not the more like professional gamers, but a lot of people would, for them, enjoy this type of thing. So the AI can take on a whole task and let the player focus on a specific aspect of the game. And maybe we should put AlphaStar in each StarCraft instance. And the minimum requirements to play the game would be like, own a GPU cluster, but we'll get there eventually. Or we can have AI coaches, right? Like imagine you're playing a sports game and you play the match, and wouldn't it be great if the AI system could tell you like, kid, you made a mistake there. How might that work? There's this concept called value functions. I mean, we're in the AI Summit, you know this, but which can take in a state and output some sort of information about how good that state is, right? So imagine you have a value function that is constantly running, looking at like where the players are, where the ball is, and then it's at the back of the engine outputting like the likelihood of a scoring, and then it's going up, and suddenly sharply drop down. And the player doesn't realize it, but our competent AI, beautiful magical AI knows this. So if we could indicate that after the fact, after the match is done to the player, like, hey, you made a mistake here. You could have been really good. Then it can actually help player learn. Learning is important in games, a theory of fun. Or the AI can point out like a very complicated path through the goal. In Celeste, there's an easy way and a hard way. So maybe I just don't want to care about figuring out where to go. And I am interested in playing the game and like going through the specific parts, but I don't want to figure out what's the best path. AI, just tell me the optimal path, I'll follow it. And there are those type of things. Or the AI can help with decision fatigue. Like in many games, there's so many options. Like AI, just give me a hero that is effective against these. Like help me learn and help me improve. Or something new. You put in your game there and you can come up with a system, AI assistance method that would be a good fit for your game. Like there's a lot of ways to go about it. So how do we come up with assistance methods then? I hear no one ask. You can sit down and think. That's a good way. Another way is to go through this design exercise. And the design exercise has 3 simple steps. Identify the different challenge types. Construct the design space of assistance methods. We'll get to what that means. And then explore the space. Simple. Let's start with identifying challenge types. Let's take Celeste again. There's the planning challenge, deciding which route to take. And then there's the execution challenge, actually pressing the button so that you jump and dash and do that in that plan that you decided. These terminology comes from the Diagnostic Taxonomy of Failure, a paper of mine, but you can come up with any technical terms. Then you construct a design space of assistance methods. What does that mean? Plop your graph. One axis execution, the other axis planning, and the length or the length of these axes represent the magnitude of assistance from the AI. And the span, the area spanned by these 2 axes is the design space of assistance methods. So on the top right, we have a traditional game playing AI. It's fully playing the game, right? Like that's what we know and love. Like in Celeste, you press go and then the AI just goes to the target. Fine. But we can also think about like what would it look like if you only assisted in a specific challenge? And now, after asking these questions, well, we can pick a point in the space and ask, like, what would that look like? What would Celeste look like if we had an AI system that only assisted in the planning challenge? Well, I call that the ghost. In our Toya implementation, we used the base from Mix and Match. It was really good. We have implemented the ghost assistance method using a star, where a ghost spawns. It shows which route to take to the goal, and then it's up to the player to actually follow that path. Or when it comes to execution assistance, well, what would it mean if the player decides where to go, but the AI handles it? Well, we call it click to move, where the player just clicks somewhere and it's up to the AI to get them there. And these 2, ghost and click to move, are the extreme points of both axes. So what happens if you just roll back? Like imagine playing Celeste with a free run assistance, where it's more like Assassin's Creed. You tell what direction to go and the AI just goes in that direction. That would be fun. Or different types of planning assistance, right? Like planning coach, you finish the Celeste level and it tells you like, hey, it could have been better. Good for some people, not as good for others. And you can actually start mixing and matching, right? So maybe it's not only one, but the AI helps in both axes. One button Celeste is one I like, where AI does everything except jumping. So the AI basically takes control of the agent, moves to the goal, and it's up to the player to press space. So Celeste becomes an endless runner, effectively. Why would that be interesting? Well, maybe maybe you're a person who can only put in binary input to the system. Maybe you need certain accessories, and that's the only thing you can do. In that case, this AI assistance system will allow you to play the same game that your friends are playing, right? So it might make games more inclusive. There's a paper out there, goes way too detail into this, but this talk is probably better. Design exercises are good and all, but does it actually work? Like I'm saying things, waving my hands, and I'm saying like, imagine all the people. I don't know yet. I'm working on it. So my current focus is using reinforcement learning for navigation assistance. This is my current target. This is a level that I've designed, and it's modeled after a small first-person shooter game, 150 meters by 150 meters and 100 meters in height. It's a first-person game. You can jump, you can double jump, and you can also do wall running. And there's different types of obstacles. You know, there are boxes and buildings and all. You have to navigate it through the space. It's built on the FPS microgame Unity template, so there's really good documentation as to how the thing works, and it's out there. So, time for a live demo. Okay. So you can see this is not the big target level because A, I can't solve it right now, and B, it makes it harder to explain what's going on. So this is the level that we're looking at, WASD moving, double jumps, all that we have. And that's the goal. The blue thing is what we want to reach. So I can just go to it, and the game will sample a new position for both the goal and the agent. Great. So if I press E, the AI assistance will take over. Now I'm pressing E, and my AI agent is basically taking me to the goal. This is basically fully playing the game. The AI is handling all the cases. It's jumping, it's doing the thing. So let's let him, all right. Another assistant method is the planning assistance, the ghost assistant I mentioned. I don't know where the target is. I press E, and there we go. So a ghost spawns, it leaves a trail, and it actually allows me to follow it. Great. Now let's see where that is. Oh, it's right there. Another type of assistance, only jump. So now I see where the goal is. Great. I'm using the WASD to move, but the AI is deciding when to jump. I'm moving toward it. Great. And I actually don't have to make decisions as to how to jump. And the flip side of it is only move. So the AI agent is controlling all movement except jumping, where the AI basically has to allow me to jump, right? So the jump input came from me. And now I can play this game with just one binary input. So hopefully this gave you a taste of what is possible. It's not there yet. The shadows are ugly. We're using the default Unity skybox, but we're looking at there. How does this work? It is trained in a reinforcement learning setup, and we have a few observations. And each model is specific to a map. So it's not a general navigation system. You need to train it on the map, and it can only work on that map. What you're looking at is one of the observations where the agent basically has an occupancy grid, and it checks whether the occupancy is filled, each box is filled or not. This is calculated offline, and it's a dictionary lookup every frame. You can also have raycasts. Not also. There are also raycasts. You can either spawn them from this type of box arrangement or right at the camera position. This gives information about the depth. And there's whiskers, where the occupancy grid is a little bit more coarser, and this gives a closer range information about what's around. And all these three observations comes in, and our reinforcement learning agent is trained basically to say, okay, reach the goal. Great. And the pipeline looks something like this. We have a Unity project. Then we export the game binary, either on Linux or Windows or what have you. And then we use the stable baselines tree, a reinforcement learning library, to actually run our learning steps. That's where the algorithms are implemented, and that's in Python. And we use the ML agents from Unity Python package, the Python API, to have our game binary talk to stable baselines. After the learning is done, we export the learn model, our Torch model, into the ONNX format, Open Neural Exchange, ONNX format somehow. And then we take that ONNX format, the outputted network, exported network, and put it back into the Unity project using Barracuda. Now we can build a new game binary that actually has the AI agent working in the way that we trained it. And this is actually running a standalone executable with GPU inference on the reinforcement learning agent. There are some other additional steps, but we can talk about the technical pipeline at another talk. And this is open source. If you're interested in exploring or playing the game that I just played, you can play it. The Unity project itself is also open source with all the levels and all the assistance methods, all the observations. I tried to write it in a good interface and object-oriented stuff. So if you want to expand on that and add new stuff, all hopefully set up to do that. The train models are also there. And this is something I'm very excited about, where a game designer can come in and say, like, okay, I have a system that takes in a state, gives me an action as an output. What can I do with this lovely thing? It doesn't only have to be assistance modes. It could be, new gameplay modes. And one thing, if you play with the assistance modes, like some of them are fun in different ways. I am very excited to implement a chasing tag type of game, but let's not move away. Experimental results. If you are a reinforcement learning researcher, the training pipelines is out there, or the experiment curves are out there, so you can compare it to baselines and some other bells and whistles. And they're all at this GitHub. Is that correct? Okay, yes, now it's cool. Okay, yeah, so we're at the QA stage. How much time we have? One question? Okay, one question. So, yeah, that person. Great talk. Well, why are you using reinforcement learning when you could be using navigation messages? Great question. Thank you. And I'm glad you enjoyed the talk. There are many reasons, but just to put it out there, if I wouldn't use reinforcement learning if I wasn't a PhD student. If I was working in a commercial game company, then this wouldn't be the approach that I would take yet. I don't think this is ready yet. Give us, like 10, 15 years and we'll get there. But to answer the actual question, reinforcement learning actually handles complex movement abilities very well. You can add dashes, jumps, and all that, and it scales relatively okay compared to navigation meshes and the added linkages. One thing that is important is reinforcement learning allows us to have the same action and traversal space as the player. That is to say, there's no point in the space where the reinforcement learning agent coverage ends. If the player can get there, the AI can get there as well. And if the player can do something, the AI can do something as well. And that actually makes it really easy to implement assistance modes because you use the same underlying controller where you don't need to translate. If the player can do it, the AI can do it as well. And finally, given a state, you can tell how good it is. All the methods that we use, we're using soft actor critic, has a value function. And this is what we talked about. You get a state, and then it tells you how good that state is. I'm really, really excited to explore how we can use this as coaching and visualization and design support. Another talk. But at the end of the day, you don't have to use competent game playing AI. Navigation meshes aren't necessarily a whole game playing AI as we call it. For these ideas, for us to assist our players, you really don't necessarily have to have game playing AI. Any type of AI system would do the trick. And more specifically, you also don't have to use competent AI or AI at all, right? The whole point of this talk isn't about reinforcement learning or using specific AI systems to support the work, but rather it's about the recognition that there are people out there that feel helpless because they bounce off from the games. And I think as the game development community, we can do better. And in the end, my conclusion is, assist your players. Thank you very much. If you have any questions, type them in chat, or you can find me at batuitems on Twitter, or email me at batuitems@gmail.com. And github.com, batu/navassist will have all the bits and pieces that I described today. If you're interested in reinforcement learning-based navigation assistance, that's where you'll find it. Thank you very much.